The laboratory method for the preparation of amines involves the reduction of nitro compounds. The reduction of nitro compounds can be carried out either by catalytic reduction using hydrogen gas in the presence of finely divided nickel palladium or platinum, or by using active metals such as iron, tin, and zinc in the presence of concentrated hydrochloric acid. In this reaction, the nascent hydrogen produced by the action of active metals with hydrochloric acid reduces the nitro compounds to amines. Note that both aliphatic and aromatic primary amines can be prepared by the reduction of the corresponding nitro compounds. For example, nitroethane on catalytic reduction or reduction in the presence of tin and HCl or iron and HCl gives ethanamine. Similarly, nitrobenzene on catalytic reduction or reduction in the presence of tin and HCl or iron and HCl gives aniline. Reduction with iron scrap and hydrochloric acid is preferred over tin and HCl. This is because the ferrous chloride formed in the reaction between iron and HCl undergoes hydrolysis and releases hydrochloric acid. Thus, only a small amount of hydrochloric acid is required to initiate the reaction. Amines can also be prepared by the ammonolysis of alkyl or benzyl halides. In this method, the carbon-halogen bond in alkyl or benzyl halides is cleaved by the nucleophile ammonia. This process of cleavage of a carbon-halogen bond by ammonia is called ammonolysis. It is also referred to as Hofmann's ammonolysis reaction in the honor of the scientist who worked on it. In this reaction, amines are produced when a mixture of an alcoholic solution of ammonia and alkyl or benzyl halide is heated in a sealed tube at 373 Kelvin. For example, when a mixture of chloroethane and alcoholic solution of ammonia are heated in a sealed tube at 373 Kelvin, a mixture of ethanamine, N-ethyl ethanamine, N-diethyl ethanamine, and tetraethyl ammonium chloride salt is produced. This is a nucleophilic substitution reaction where the halogen atom is substituted by the amino group. The primary amine thus obtained acts as a nucleophile and reacts further with more of alkyl halide to form secondary and tertiary amines as well as quaternary ammonium salt. The free amine can be obtained from the ammonium salt on treatment with a strong base such as sodium hydroxide. Ammonolysis has the disadvantage of yielding a mixture of primary, secondary, and tertiary amines besides a quaternary ammonium salt, which is difficult to separate. However, the actual composition of the reaction mixture depends upon the ratio of alkyl halide and ammonia used. If an excess of alcoholic solution of ammonia is used, then a primary amine is formed as the major product. However, if excess alkyl halide is used, then a quaternary ammonium salt is formed as the major product. Amines can also be prepared by the reduction of nitriles and isonitriles. The reduction of nitriles with lithium aluminium hydride or with hydrogen in the presence of catalysts such as platinum, nickel or palladium yields primary amines. For example, ethane nitrile on reduction with lithium aluminium hydride or catalytic reduction gives ethanamine. This reaction has synthetic importance as it is used to step up the carbon chain. Alkyl nitriles can be easily prepared by the action of alcoholic sodium cyanide or potassium cyanide on alkyl halide. Alkyl nitriles thus formed are reduced to get the primary amines. This is an excellent method for the preparation of primary amines. For example, methyl bromide on treatment with alcoholic sodium or potassium cyanide gives ethane nitrile. This on reduction with hydrogen in the presence of nickel as the catalyst gives ethanamine. The reduction of isonitriles or carbyl amines yields secondary amines. For example, ethyl isocyanide on reduction gives ethyl methyl amine, which is a secondary amine. In this method, we get only secondary amines in which one group is always the methyl group. Another method for the preparation of amines is the reduction of amides. Amides on reduction with lithium aluminium hydride yield amines. For example, ethanamide on reduction with lithium aluminium hydride gives ethanamine. A convenient method for the preparation of aliphatic primary amines is Gabriel's phthalimide synthesis. In this method, phthalimide is treated with ethanolic potassium hydroxide to yield potassium phthalimide. This potassium salt of phthalimide, on heating with a suitable alkyl halide, gives N-substituted phthalimide. The subsequent alkaline hydrolysis of N-substituted phthalimide results in the formation of the corresponding primary amine. For example, phthalimide on treatment with alcoholic potassium hydroxide gives potassium phthalimide. This, on heating with ethyl iodide, gives N-ethyl phthalimide. The alkaline hydrolysis of N-ethyl phthalimide gives ethyl amine and phthalic acid. Let us look at yet another important method for the preparation of amines. Hoffman's bromamide degradation reaction. Hoffman developed a method for preparing primary amines by treating an amide with bromine in an aqueous or alcoholic solution of sodium hydroxide. For example, ethanamide on treatment with bromine in the presence of sodium hydroxide gives methanamine. Note that in this reaction, the resultant amine formed has one carbon atom less than the parent amide. Hence, this reaction is used to step down the carbon chain. Let us look at the mechanism of the reaction. As you can see, the first step involves the halogenation of amide to yield N-haloamide. The second step is the abstraction of hydrogen ion by the hydroxide ion. This results in the development of a negative charge on the nitrogen atom. Step 3 involves the separation of halide ion, resulting in the formation of an intermediate with an electron-deficient nitrogen atom. Step 4 involves the migration of the alkyl group from the carbonyl carbon of the amide to the electron-deficient nitrogen atom. This results in the formation of alkyl isocyanate. The last step is the hydrolysis of alkyne isocyanate to yield a primary amine with one carbon atom less than the parent amide. With the knowledge that we have acquired about the methods for the preparation of amines, let us now carry out some conversions. Benzene to aniline, chloroethane to propanamine. In the conversion of benzene to aniline, the first step involves the nitration of benzene using the nitration mixture to nitrobenzene. The nitrobenzene formed in the first step is reduced to aniline in the presence of iron and concentrated hydrochloric acid or by catalytic reduction. Let's proceed to the conversion of chloroethane to propanamine. Note that this conversion involves the stepping up of the carbon chain. To achieve this, chloroethane is first treated with an ethanolic solution of sodium cyanide to yield propane nitrile. In the next step, propane nitrile is reduced by active metals like tin, iron, or zinc in the presence of concentrated hydrochloric acid or by catalytic hydrogenation to give propanamine.